The purpose of this section is to familiarize you with centripetal force. Before we get into centripetal force, we are going to review a couple of things we have covered in previous chapters. First, let's start with Newton's first law of motion, which states that any moving object tends to continue at the same speed and in a straight line unless an outside force acts on it. This will be very important to remember that in order to change direction, an outside force must act on an object. Next, remember that a force parallel or acting in the same direction to motion will speed up the object, but a force opposing the motion will slow down the object. A great example of this would be friction or rolling resistance, as well as air drag. Both of these forces act in the opposite direction that the bicycle or the wagon are traveling, so these forces tend to slow down the motion. Now let's talk about centripetal force. A force from the side will push an object in a curved path. Centripetal force causes an object to move in a circular path. Centripetal force pulls towards the center of the circle. Some of you may have also heard of centrifugal force. Centrifugal force acts in the opposite direction of centripetal force. We won't worry about centrifugal force in this class. As we can see in this picture, as the car goes around the racetrack, there is a force directed towards the center of the circle. This is the centripetal force. We can solve for centripetal force as long as we have the mass of the object, the speed of the object, and the radius of the object. Centripetal force is equal to mass multiplied by the speed squared. Make sure you only square speed. Our units for centripetal force are the same as any other force: pounds in the English system, newtons in the metric system. Mass needs to be in slugs in the English system, speed is in feet per second, and the radius must be in feet. In the metric system, mass is in kilograms, speed is measured in meters per second, and the radius is measured in meters. This schematic is meant to demonstrate that the centripetal force is directed towards the center of the circle or the center of the curve. In the next video, we will take a look at an example of how to calculate the centripetal force.